Are we good now? Yes. Okay. Final day. And if I leave this talk early, it's because I need to have a nap. I apologize. Thank you very much for making it all here, for all making it here. Yes, I am tired. Stayed out late with the team last night. Had a great YAPC Perl conference. I had a lot of fun here. And I wanted to do something a little bit different with this keynote from some of the things I've done before. I want to talk about something a little bit more aspirational than what we've had in some of my other talks, looking towards the future and what the possibilities are. So what we could do, but this is just me speaking. I'm not speaking for the Perl Foundation. I'm not speaking for Perl 5 porters. It's just stuff I would like to see that I think would help. I'm gonna cover both Perl 5 and 6 though, and they're gonna be a little bit different in structure. So of course you know who I am by now, Curtis Poe, better known as Ovid, all around the world, training, consulting, helping folks out. If you have any questions, just want to chat, let me know, of course. But let's talk about Perl 10 years from now. I had so much fun. Actually, that's his nose, it's not your nose, so don't feel bad about that. I want to make that clear. And if you take away the top layer of that in GIMP, it's pretty scary because I had to like smudge out the eyes underneath. It was a lot of fun. I almost put myself up there, but that seemed pretty cheeky. So, yes, Larry, you'll be here in 10 years' time. So this is going to be talking about Perl 5 and Perl 6, but I'm going to start out talking about Perl 5. And I want you to take everything I say with a grain of salt. Because again, this is just me speaking. Some of the things I would like to see. But a grain of salt is actually a really interesting metaphor in this particular case. Because in the 1970s, Dr. Louis Dahl gave salt to rats. They got high blood pressure. Oh my God, we're going to get high blood pressure. It's terrible. And everyone's saying you can't use salt. Don't use salt. My mother-in-law says this to me all the time when she sees me salt my food. There was a couple of interesting flaws in the study they discovered, though. One, turns out he experimented on rats, not humans. Two, the equivalent of salt was about 150 times what we have in our daily intake. So now, there's a lot of studies that show salt's perfectly fine. Salt your bacon. It's not going to hurt you. It might taste odd. But even though we know that salt isn't actually bad for us, we don't listen. Perception is everything. Perception is a huge amount. So when we're talking about things that we could do for the future of Perl 5, what the possibilities are, don't just think of, this is exactly what I think it should be. What do other people think it should be? Because perception is really important, and it is just as important as reality at times. Speaking of perception, here's the slide everyone's going to hate me for. TIOB. Perception's important. People pay attention. It's one of the quickest hits on the web if you're looking for language statistics. And this looks kind of depressing, but the reality is Perl's actually stabilized for about 7 years now. That was longer than I thought. So yes, we're not at the heights that we once were, but we're doing rather well. If you're concerned about these ups and downs in the graph, there's medication you can get. If we want to consider the Institute for Electrical and Electronic Engineers, they actually have Perl down here at number 17 in a different type of ranking, but if we filter just for web development, we're up to about 10. It's stable. It's doing well. You can go out there. I'll eventually get these slides online. You can follow the links to find out what they did to arrive at these numbers. But let's be honest. We're talking about Perl 5. It's got a bit of a rocky history. It's been a bit difficult. And part of that is because we've been the trailblazers. We have made every possible mistake you could possibly make in a programming language, and others said, I ain't going to do that. So we've helped so many people simply by making the errors before they could. So it's been a bit rough at times, but there's still a huge amount of potential. And a lot of the stuff, we can see more of the potential with things like keyword declare and other things which allow us to play with the language and see what we could do instead of what we are doing. So when I was thinking about this talk, I had 3 goals in mind. My first version was absolutely terrible, and I decided, okay, I want things which are achievable, things which are realistic, things we actually could do. I don't want any magic in there. I don't want anything too funky, and it still has to look like Perl 5 when we're done for the Perl 5 section. Perl 6, like I said, I'll cover that later. I'm not asking people to pick up pitchforks. If you do, okay, fine, but I didn't ask for it. That's my disclaimer, please. So everyone hates a Fibonacci function because nobody writes a Fibonacci function. There is something called a Fibonacci sort, which is used for hardware limitations, which I won't go into right now. There's a few other use cases, but no one uses it. But from a pedagogic standpoint, Fibonacci is wonderful for teaching a lot of things about computers. So I love to use it, even if you don't. Too bad. It's my talk. So how many people would write a Fibonacci function like this? This was my first pass. Looked perfectly reasonable. Yeah, I see a lot of people nodding. No, Ilya, you can't answer. You've done code reviews on my code, and I know what you're going to say. You're going to tear this to shreds. So it looks perfectly reasonable as a first pass of a Fibonacci function, but if we pass in a -2 or a 1.3 or an undef or a string or a type glob or whatever, that's going to cause us all sorts of problems. So I was thinking about this. How can I, in Perl 5, write a Fibonacci function which is actually correct? And why is that important? Because I work on a lot of big systems, and this type of code bites us all the frickin' time. Making it hard to write correct code. It's fine for a module you release on the cPanel. You get some tests you play around with a little bit. You can nail that down. Right now, our game Tau station, if you combine the templates, the JavaScript, and the tests in the actual code, we're about 1/3 of a million lines. This hurts us if we get sloppy. That was my attempt at writing a correct Fibonacci function in core Perl 5. Nothing fancy, nothing unusual. This is still not perfect. There are some problems, but there gets a point when it gets a little frustrating. So I decided to stop like that. Now, the reason for this is, first of all, if we're going to really be correct, we want to make sure we actually had an argument. We shift the argument off. That's why we shift after we check for the number of arguments. We croak if that's not defined. Then we croak if it's not a positive integer. And then we have the actual stuff we wanted to do. There's only 2 lines we want to do there. So C, of course, is notoriously verbose. What does a correct one look like in C? Yeah, I hear silence. Why? Because that's embarrassing. We shouldn't be there. So let's think about signatures. Just very simple signatures. Nothing, just declare a variable. Right off the bat, that's 2 lines we get to delete from that. Already, this is looking a little bit better. We can't delete this because if you pass undef to the Fibonacci function, you still have to check for it. So we're getting a little bit closer. It's a little bit easier. When you're building a large system, you want your code to be correct. So signatures help with this tremendously. And I can't even begin to tell you how important this is. With all my clients, signatures is the one experimental feature that I find they're using in production all over the place. That is how incredibly valuable they are. But they've been experimental for over 4 years, and they have to remain stable for 2 years before they can be non-experimental. We just had to change it again because of the attribute order, which means they're going to be experimental for at least 6 years, if not more, for a feature that most languages have had before we've even been born. So, yes, I'm a little frustrated by that, but we use signatures all the time in our work, and oh my goodness, it saves us a lot. It's often used production code. It catches so many darned errors that you just don't think about, and also a lot of unspoken assumptions. You're using some other code, and it's calling you, and you don't realize the arguments it's going to pass it. They're great. But this is what we actually have. So gradual typing is an interesting thing. Obviously, they're doing this in Perl 6, and I've read some articles of people talking about their experiences with gradual typing with other languages. And one of the problems they have with that gradual typing is generally it's a third-party module. Because it's third-party, it doesn't integrate directly into the languages, and they have problems with their gradual typing interoperating correctly with other packages. They have problems that you can't optimize it very well because it's not in the core language. It would be nice if we had gradual typing, and if I could simply declare that an unsigned integer. Unsigned integer nth, all of a sudden, that 4 lines of boilerplate is gone. That gets us down to the code that we actually want, which is, like what we'd see in the C code. And it's more correct. It's easy to write correct code if we do something like this. So I don't just want signatures in 10 years. I want very simple types. I would like to have more than very simple types, but I'm, achievable, realistic, less controversial. And when I'm building a large system, this really saves you. So it's interesting because this is actually what we call a pure function. A pure function, you give it a set of arguments, it is guaranteed to return the same return values for that set of arguments, and also is guaranteed, a pure function is not supposed to have any side effects. So a pure function will never open a file handle, for example. So a pure function, well, this would be kind of interesting. What if we defined a pure function? So we can replace the sub keyword with a pure keyword. So pure functions are great, have an attribute right there saying it's a pure function. They're obvious candidates for caching, but maybe we can find ways of caching pure functions internally. Lots of danger with that, but pure functions, they have some interesting properties. There's a lot of compile time checking you could do. You'd have to ensure that they only use lexical variables. You might have to do deep copy to avoid side effects. You couldn't have open, select, eval. They are thread safe though. Memoizing is nice and safe. They're safe for inlining, which is really important. And lazy evaluation becomes interesting because if you assign something from a pure function and you don't actually use that return value, you don't have to evaluate the function. Your code's faster. And here's my co-presenter, Robbie the Robot, saying, "Danger, Will Robinson." Earlier I said no magic. This was one of my first attempts at the talk, and I started to go down a magical path because this has all sorts of interesting side effects. It's great for Perl 6, it's less great for Perl 5. But the inlining, so I decided to just pick that out. What's interesting for inlining? So here we have some code. We're going to sum the reciprocals up to 50 million. That comes out to a little bit over 18. It's about 18.3. So we're going to sum the reciprocals to 50 million. And here we have a reciprocal function. I know it's stupid, but it's just a simple example. Reciprocal. We call the function. Takes 9 seconds to run that. I now inline the reciprocal function here, and it takes 2.5 seconds. Inlining is a huge win. It's one of the things we're doing a lot with Perl 6 to get performance wins. It is not a theoretical problem either. This has been attempted in Perl 6 or Perl 5 a number of times. And we've had a couple of clients who work with big data, and they've had problems where it takes them over a day to process a day's worth of data, and that's somewhat suboptimal. You don't catch up. And for one of them, I said, well, let me go ahead and see your profile of your code. What's performance like? And they showed it to me. It's like, I'm looking at this, and oh, wow, this subroutine is called a lot. And it's really slow, and I'm looking at it, and I couldn't figure out how to speed the subroutine up. But it was called at the bottom of a really deep loop in their big data processing, and I couldn't figure out any way to extract it cleanly, so I said, let's go ahead and try this. We're going to put comments all through the code where you call this, and you're going to copy and paste the code into there. Because this is being called at the bottom of a tight loop, and you're going to document the heck out of this so everyone knows that you're copying and pasting the code, and they got a significant performance speed up just by not having that extra subroutine call. But they had to manually inline it, which means they duplicated this code all over the place. Wouldn't it be nice if you had an inline keyword which does it for you? So in this case, to do it a little bit safer, the syntax is inline, block, do, block, right here. Copy over the arguments like this. That drops it from 9 seconds to 6 seconds. This is not magic. This is achievable. And this would be a huge performance boost for many applications. Now, the interesting thing about this, so the syntax is just the same as a subroutine. You replace sub with inline. And Robbie says I'm a moron. He's right. There are problems with this. It's a little frustrating at times. It would behave just like a regular sub. It might, for the first pass, require a single return statement at the end of the subroutine because we're talking about just effectively replacing it with a do block. And even then, you would just evaluate the last thing and not return it, but we'll ignore that. If you have a recursive inline, if you have an inline function which calls another inline function, which in turn calls that first inline function, that ain't going to work. So you would have a warning, and the inline becomes a sub, and it just works like normal. Your code's just not quite as fast. If you want to, you can make it fatal. Your code fails, and you can go in and take a look at it. It's not hard to do this in theory, and would gain us a lot of benefits through just a simple change like that. But that's enough of that. I'm talking about little simple things. Here's a big thing that everyone talks about all the time. Let's show a little class. Hi, Robbie. So, time to learn some Python. Here is core Python. Very minimalist. There's nothing fancy about this. We're creating a simple XY point class, and inverted inverts the point. And nothing interesting, but it's a little bit of code which you can actually see. It's very simple. We have a class keyword right there. This is how you do inheritance. If you want multiple inheritance, you just pass it a comma-separated list of class names. We have a default initializer. That's like the build method we'd see in Moose or Moo. We have signatures. Sorry. And there's no self keyword. Methods are just object-bound subroutines, just like Perl 5. So it's not terribly different from Perl 5. It's almost, except for some syntactical things, what we have. But you've just learned OO Python in 5 slides. 5 slides. You can't do that in Perl 5. Not with core Perl 5. Not quite that easily. I've done some hand waving here, like ignoring things like super and stuff like that. But let's take a look at this minimalist Python. Here's writing this point class and returning an inverted point in core Python. Let's do it in core Perl 5. That's effectively the same behavior. You'll just have to trust me on it. It's a little bit too minimal for core Perl 5. So in Perl, we have Moose, Moo, some other things out there. Python really doesn't have alternative object systems. They've tried a few times, and in 3.7 they're doing something a little bit more. But for the most part, they've stuck with core Python because it's been just enough sugar to give them what they wanted, and they've been happy with it. They managed to find the sweet spot in the sugar. Yeah. And it's easy to use. Look at that. 0.37 inverted equals point inverted. You print out the x and y values to make sure it's inverted. You assign foo to O. Well, that's really interesting. I'm effectively reaching into the object and assigning a string to something I want to be a number. And I've talked quite a bit to members of the Python community, and they assure me changing this is unPythonic. Getters and setters and validating your data is unPythonic. Now, some of you may remember the early days of Java in the mid-1990s when they were declaring all of their attributes as public and you could assign to them directly. At least in Java, you had types, and you had a little bit of control. And even then, they realized this is a bad idea. They stopped doing it. We, the freewheeling hackers, realized a long time ago, this is not a good idea. We stopped doing it. So I was digging into Python, trying to figure out what's going on. And both their 2 and 3 documentation, it says private instance variables don't exist in Python. Danger, Will Robinson. Hi, Robbie. Again, this is hand waving. Everything I say, there's a lot of caveats. There are things you can do in Python to get a little bit more safety. But I want to have some comparing and contrasting between different languages so we can see what our potential can be. Because if we have stolen so much from others, let's keep stealing. So here's core Python. There's core Ruby, same thing. Pretty easy to do. There's our core Perl 5. What would a minimalist OO in Perl 5 look like? Here's my first shot. That is really simple, easy to use. Notice we have the optional gradual typing there. We have num for x and y. Here's your inverted. There's a lot more I could say about this slide, but part of it is very declarative. It's very clear. It's still clearly Perl 5. I don't think anyone's going to say that's not Perl 5, even though obviously there's a little bit more to it. There is so much we could do to tremendously improve what we have. But, if you come to Perl and you're a Ruby programmer, you're a Python programmer, and you already have this minimalist core object-oriented programming, you've got to learn object-oriented programming in Perl. So the first thing you do is you read Perl.Perl object, and the first thing that does is it says, actually, you don't want to read me yet. You want to read these others. So Perl OO toot and Perl ref. I wish this said Perl ref toot because if you're Python or Ruby and you start out reading Perl ref, you're going to quit your job. It's scary. Perl ref toot is a lot easier. So we go over to Perl 00 toot, and what does that do? It actually doesn't teach you how to write. It doesn't teach you how to write object-oriented code using Perl 5. It tells you what objects are, more or less. And it also references moose, moo, class accessor, class tiny antlers, and role tiny. What's wrong with the cPan, though? We like the cPan. In Python, there is one way to do it. And this has taken them very, very, very far. We should not disregard the success of that idea. For Perl 5, we say, you need an object system. You need an object system. I need an object system. You hate objects, whatever, that's fine. But everyone has different needs. So you go out to the cPan, we tell this new developer, and you find the object system which fits your needs. So this new developer, I'm going to check the cPan and look for object systems. Go ahead, find your favorite system. Sorry, Inge, I don't think Bloom is on the slide, but I can't tell. There is some fascinating stuff out there. Python, yes, I deliberately shuffled those so you can't find yours very easily. I want people to look and pay attention. This is the state that we are in right now, and it's not a good state to be. Python doesn't have this because they've provided just enough sugar to make it work. So, as part of the Perl 6 part, I was playing around with Perl 6, seeing what we could do, and I was writing an LRU cache. And I said, well, actually, LRU cache is really simple, and we want a more reasonable code example on the slide. So why don't I do this on the Perl 5 slide, and on the Perl 5 side of the talk, and I decided I'm going to look for LRU cache in Python, so I can have something to compare and contrast for this minimal viable object-oriented programming of Perl 5. So this was from a developer. I'm not going to go ahead and list their blog entry because there's actually a problem there, and I don't want to embarrass them. But they wrote this saying, this is an example of better Python because originally it was ON, and now this is O1. And my code presenter would like to remind us that O1 does not mean fast. It means constant time. If I pass 1 argument or 100 arguments to a subroutine and it still takes a year to run, it is O1. So this is fascinating when we dig in here. Does anyone see any problems? You don't have to know Python, but there are 2 huge issues with this. Okay. Number 1, we'll take the easy one right now. What happens in your cache if you want to store the value -1? Yeah, so they're going to return -1 for an error. This person was obviously a C programmer in a former life. The next problem right here, the try block. So try is very inexpensive in Python, up until you get an exception. What happens with exceptions? Exceptions, basically, they get thrown, they have to walk up the call stack, they have to gather up this information. They're very slow, but when your data center is burning down, you don't care if your exception's slow. It's not a big problem. Exceptions, however, really cause a problem. And if you have a cache, particularly an LRU cache, you're going to get a lot of cache misses, which means you're going to get a lot of exceptions. An exception should be for exceptional things, for things that you don't expect to happen, not for the core case. But what happens if we try and pop a key off which doesn't exist, we get an exception. So that's really slow. Turns out, all we have to do is check to see if the key's in the cache, then we can get rid of the exception handling. And if that case doesn't hit, this function will return none. So not only does that get rid of the exception handling, which we didn't want, it also gets rid of the problem with the -1. We have cleaner, more correct code. And I wanted to do that because I wanted to be as fair as I could to Python, in addition to Perl. So this is our cleaned up Python code that we have right there. I know you folks are hating me for this one. This is our minimalist OO using less in Perl 5. Python, their minimalist OO, Perl 5. Here's Moose. Yeah, that ain't much shorter. It does have the advantage that that section is declarative. When you can switch from procedural code, telling it step by step, this is what you're going to do, over to declarative code, you do have a nice win, but I'm not going to go into that. So Moose still has some advantages there. But with the minimalist OO idea I had, what would it look like then? It would be fairly simple. It would be clean. We have a class cache LRU, use hash ordered. A my variable inside of that block would be a private function, a private method attribute. The has would be public. You've got your get and set methods. There's nothing fancy about this. And what I particularly like about this particular example, oh yeah, Steven says, damn it. What I like about this example is we actually have a number of modules on the cPanel now who can basically get you that syntax. I'm not saying there's a syntax we have to have, but it's a nice syntax. And if we compare it, it's cleaner than the Python. The Python, you actually have to add some extra code in order to handle some of the checks which are built in over there. And you do have the problem with the private attributes in Python, be considered Pythonic. You get a lot of wins going with just a minimal bit of class, minimal bit of sugar. But it needs to be core if that's ever going to happen in Perl 5. Because then you can have a standard that everyone can base upon. And you don't want it to be too much or too fancy. But here, we would actually leapfrog many of the other dynamic languages in terms of what we can do with our object-oriented programming. This is very clear. It's very easy. The only parts of this which are actual code, non-declarative code, is the stuff that you actually have to think about. You have to design the logic for. The rest of it's all nice and declarative, and it's clean. And that would be a lovely thing to see. And we can get there if people would actually put their mind to it and say it and decide that they're going to do it. So there's a whole bunch of things we could ask for that I don't care. Actually, I do care in many ways. But the simple things, gradual typing, function signatures, a nice, clean, simple, minimal object syntax would push Perl so much farther. And Perl 5 would actually be easily able to stand on its feet against many of the other dynamic languages too. It's not hard. We could do that. We could do that within 10 years. But that's enough of Perl 5. We're here to talk about Perl 6. Perl 6, I'm taking a completely different track on this. Wither, Perl 6. When I wrote this slide, I actually sat back and wondered, is wither an async keyword? Probably is. So, oh, I need to expand that. That's too small. Sorry, you won't see this change. OK. So before we talk about this, here's one thing I want to caution for a lot of Perl 5 developers. Perl 6 is not Perl 5++. I have seen this so many times. Perl 5 developers, such as myself, approach Perl 6. We try and write Perl 6 code, and we fall flat on our face. For the same reason that 20 years ago, we used to say to Perl 5 developers, don't write your Perl code like you're a C programmer, because they would. Or in my case, believe it or not, it was don't write your Perl code like you're a COBOL programmer, because I did. It was an embarrassment, and I'm glad you can't see that code today. So for Perl 6, you need to think about it as a sister language. It really is not a successor. It is a separate language, and you need to learn its idioms. You need to learn how it works. And just to give you an example, when I was writing that LRU cache in Perl 6, just playing around with it, this is a very Perl 5 style, and there's nothing wrong with this in Perl 6, by the way. So this probably isn't the best example. But Liz, she said, oh, that looks pretty cool. Let me try my hand at it. So now I can just say that this hash is an LRU cache. And I don't actually have to learn any new syntax, though I do have to learn behavior. So you can do that in Perl 5 with tie. How many of you know you could sit down and write a tied hash without looking at the docs and it will work? Yeah, that's what I thought. So it's a lovely little bit, and it's thinking about Perl 6 in a different way than you would think about Perl 5. It never would have occurred to me to do this, but it's trivial to do in Perl 6. Perl 6 has come a long way, though, and let's face it, Camellia, it's been a little bit rocky for her, too. I feel kind of bad. We've had a few struggles. But let's be a little bit aspirational. Let's talk about new features that I want for Perl 6. Are you serious? No. Anybody remember this? Periodic table of operators. It's a bit out of date. It was a beautiful piece of art. But let's face facts. Perl 6, there's nothing new that I want for Perl 6, except, well, maybe to show up a little bit more outside of the Perl 6 world. So actually, that's a beautiful little dotted graph in there, but it's not showing up. So let's take a look at something else, though, and figure out how they got there. So here's Go. When Go was first announced, there was a lot of interest in it, and then it kind of plummeted. And then here, around 2013, Docker was released. and Go started picking up some popularity. And then I don't know what happened in 2016. I did a lot of research, and I just couldn't figure it out exactly, but Go shot up in popularity. Job boards like DICE started mentioning tons of Go jobs available. Yes? Pardon? Oh, Kubernetes. Thank you. So yeah, that would explain it. So Go it's kind of trapped in the DevOps world, but it's a beautiful language. I've done programming in it for Tau Station, for writing our bots. It's really easy to use. It's a great tool, but what is it which helped Go? Part of it was the simplicity. Okay, Perl 6 ain't going to get that. Part of it was the speed. I mean, Go is, well, it's simple, it's easy to use, it's really, really fast. It's not as fast as C, but it's an easy to use language which is really fast. And that's important because CPU speeds. So here we are, 2009, this AMD was 3.7 gigahertz, and here, 2018, 4.2 gigahertz. The CPUs ain't getting faster, folks. And they're slapping a whole bunch of caches on there as part of their many strategies to figure this out. It's not going to happen. If hardware can't get faster, software has to. In particular, the programming languages that we use. That is the key challenge we're facing. So Go handles part of this because it's just fast, and part of it because it's Go routines and it's beautiful concurrency. But we're not going to talk about concurrency right now because we already know Perl 6 concurrency is magnificent. Instead, micro-benchmarking. Yeah, everyone loves that, don't you? You can hate me later. Oh, you can hate me now. I don't care. Here, we're going to assign 100 million integers to an array in Perl 6. Do the same thing in Perl 5. And you can see 6 seconds versus 12 seconds. Perl 6 is twice as fast in this example than Perl 5. This is the potential of Perl 6. But, this is a micro benchmark, and everyone's saying, oh, no, why are you doing a micro benchmark? That's not real. So let's do something with just a little bit more reality here. Here's a very simple point class where we're going to assign x and y values. We're going to create 500,000 random points. And we're going to do the same thing in this nice terse Perl 5 code. And 13 seconds versus 1.2 seconds. It's an order of magnitude slower for Perl 6. That's the problem. You solve that. There's so many other opportunities. So many people love Perl 6, not because of this one cool feature. I see this with so many languages. It's got this one cool feature I want. And with Perl 6, so many people say, it's that one cool feature, or that one cool feature, or that one cool feature, and that stops everything right there. So what's going to happen? Speeding up Perl 6. Thank you, Jonathan Worthington. I stole all of this from him, so there's nothing brilliant about this. So this, in June release of Rakudo, creating 10 million sets of 4 numbers took 81 seconds, and now, down to half a second in the July release, that's 2 orders of magnitude faster. That is huge. That's wonderful. But how did they actually do that? Part of what's been going on actually is initially a lot of the core code is written in C, and you can't really optimize the C because there's a lot of stuff you're about to see. I didn't mean that. There's a lot of stuff you're about to see, which you can't do with the C code, but you can do with Perl 6 code. So they've been rewriting a lot of the C code into Perl 6 code, making it slower in order to make it faster. But you'll see why. So what happens when you run a Perl 6 program? We know this is different from Perl 5. We have our source code. It's parsed by a grammar. Wow. It's turned into an abstract syntax tree. First, make it right, and then it's turned into an optimized abstract syntax tree. Then make it fast. Then we generate the bytecode, and we execute the bytecode. Now, what happens in that step 4, optimizing the AST? So yeah, there's not a lot. So we have constant folding. You see the number 7 plus 3. It just turns that into a 10. Or eliminating unnecessary scopes. Every scope is a closure. That's going to take away some memory. We don't need all the setup for that. So if the scope isn't needed, that goes away. Inlining native operators. If you have multiplication, that's actually a subroutine, which needs to figure out how it's going to multiply the 2 arguments. And if the compiler can figure out how to do that, it'll simply replace that with multiplication instead of the subcall. If it sees that internally it can rewrite your code to something faster, it'll do so. And yeah, that's about it. That's the sort of stuff that Perl 5 can do. But there's a problem with that. It doesn't know that that little lonely subroutine off in the corner taking an integer is going to be called 73 million times. It doesn't know anything about your type system at compile time because it doesn't know what types are going to go through there with the way it's set up. Correction, it does know about your type system. It doesn't necessarily know how those types are going to be used in the program. And it can't know what code's actually going to be hot. That's not possible. And this is a common issue. So what actually happens here? So many of you are probably familiar with the fact that you run Java long enough, and Java often, the program will speed up over time. This happens with Perl 6. And how does it do that? Because we can know a lot of this information at runtime via interpreter logging. So basically what happens is when you're running the code, it sees what's going on, and it starts tracking what's being called and passed around, what's hot, and it logs that. And it turns out it can log it so efficiently, there's no noticeable performance impact for that. And this is really important because then we get to an optimizer thread, which while your program's doing its stuff, the optimizer thread is reading your interpreter log, and it's building a model of the program. And it's figuring out what's slow, what's not slow. Or as I like to say, am I hot or not? So total calls to code tells us if it's hot. The arguments that it's being called with tells us what to optimize for. And there's a lot of trade-offs you have to figure out. A lot of things, if you have a much longer section of byte code, it's going to take longer to optimize. So you got to decide, do I want to optimize that or not? But this is the short version of how it works. Your planner, imagine a C set defined is called a little over 2,000 times, 3 times with a string, 2 times with a number, and all the rest of the times with an integer. So now we know we optimize for an integer. So what happens is internally, it has a code which says, OK, I'm going to get called with an integer. I know exactly what I'm going to do. It has a fast guard in there that verifies that you have an integer. If you have an integer, you run the fast code. If you don't have an integer, you run the slow code. So this is the chars method. Before optimization, this is really the only work. But it has to do all this stuff to figure out stuff about your arguments and all this stuff to figure out stuff about your return value. This is all you really want. After this gets optimized, that's all you got. Your bytecode shrinks tremendously. So optimizations that are actually working for Perl 6 or going to be working. So, making method lookups faster. If you know you're calling the bark method on your dog, just call it directly. Don't look it up. Skipping multi-method lookup. If you know you're probably going to be calling that one multifunction, or you're definitely going to be calling it, just call it directly. Skip the hash lookup. Inlining, you might remember that from earlier. That's always a huge win. There's many more optimizations that they're looking at for that. They're looking at escape analysis. So escape analysis, if you have memory, which is only used in a subroutine or a method, you don't need to put it on the heap. You can just put it on the stack, which means the garbage collector doesn't have to worry about it. It's much easier to take care of. If you can avoid the garbage collector, that's a win. So avoiding unboxing is lovely. If you have an array of integers and it creates a whole bunch of integer objects and passes that off to another function, which then takes out the integer values from all the integer objects and then does something with those values, that doesn't help. That's what we call unboxing, boxing and unboxing those values. If you can figure out that it's actually going to use the raw value and I don't need anything else with that, then I can skip that. There's another huge win there. More inlining. And then once you inline some code, you can then re-optimize that AST there and attempt to you inline some code and re-optimize that. There's so many huge wins there. And actually what this means is that in July Perl 6 performance report, private method calls were 6.5 times faster. If you had a qualified method call, that was 12 times faster. Optional dispatches, that question mark means it's only going to call the foo method if the foo method exists. That's about twice as fast. These things are showing up all over the place, and it's rapidly accelerating. But you want to know when. So talking with Jonathan, realistically, this could be done within a year, but there's not enough people. There's uncertainty about availability, what's going to happen if you define something in the code which takes more time to work around. We can get this there. But Robbie the robot says that's actually a little bit optimistic. I shouldn't be making promises. I'm definitely not making promises on their behalf because I don't want to do that. But the interesting thing about this is they have been continually improving in performance. Perl 6 is so much faster than it used to be. they've got great tools to continue doing this, better tools than you can possibly have for Perl 5. And they are not running out of ideas at all for all sorts of different ways to optimize it. And what's eventually going to happen is Perl 6 is going to, in the general case, catch up with Perl 5 and then say, sayonara, sucker. It's going to be long gone. There's nothing you can do about that. Because Perl 5 will never be able to catch up with Perl 6 at that point. So, we're coming to the end. And I just want to share this one weird thing. I don't know what this is, and it has nothing to do with the talk whatsoever. But it's just something which stuck in my head. The $sign. When you're writing object-oriented code, that $sign looks like an S, so I see an S. My code is infested with elves. And there's no reason to put this here, but then I realized Robbie the robot has an interesting little secret, and he wants to say goodbye too. He likes the elf Galadriel. So I want to thank all of you very much. I hope this has given you some interesting stuff to think about. Perl 6 is well on its way. It's doing its stuff. They're doing great. If you want to contribute to that, I think it's absolutely wonderful. Perl 5, I think we have a huge amount of potential. Just a few small changes in the language will dramatically improve the quality and the support for scalability in large systems. So think about that. Talk about that. If you want to bug P5P, don't bring a pitchfork, or if you do, don't mention my name, please. Nick. I'm sorry? Oh, the maintenance funds. Yes. In order to keep this work going, it's very helpful if we can pay people so they can afford to work on this. So there are still the maintenance funds out there. They're available. Please contribute to the Perl 5 Core Maintenance Fund, the Perl 6 Maintenance Fund. This helps us realize these achievements. And if you can even send them an email saying, this is the money I'm sending. I would love it if you can work on this. There's no promises that they can, because it's always a difficult thing. But that does help them to get some sort of idea of the use cases people would actually have for stuff like that. Does anyone have any questions? Turns out we've got a few minutes. No, that was simple. Great. You folks have a wonderful rest of the conference. I guess it'll be lightning talks now.